they encountered as they studied.
17.
Nice. A question that first hour didn't ask. Very good. Let's see. Dupe. Wrong place. Dupe. Nope. There we go. All right. I'm guessing this is a prove that this is true thing. Even though it doesn't say it, I know that's kind of mean of me. I'm sorry. Totally should have said what to do in that one little section. But usually it's proof that this is true. Can I not copy and paste? Is that not allowed anymore? Paste. Hello. All right. So we got to prove that it's true type thing. And some of us might have better intuition than others on what exactly to do. Anybody have like a... Oh, I know what I would do first. You don't have to be me. You can try something else. What would you try? I would do sines and cosines first. That's just me. I like doing it because I don't like having to worry. So you're saying sine over cosine all over 1 minus cosine. Let's just go ahead and do this all the way across the problem. Equals. Anybody have any idea about cosecant? Indeed. I'm going to do a good job today of not shorthanding any of this. I'm going to write out the sine of x every single time. And then 1 plus secant turns into 1 over cosine of x. 1 second. I kind of want to check something because I totes forgot. Zoop. Zoop, 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 zoop. Zoop, zoop. Zoop. Use space, free space. Okay, sweet. We're good. Yay. All right. Oh, that just made it uglier, not easier. Dang it. Crap.
What?
I just think it made it uglier, not easier. It's very ugly. All right. Anybody got any other thoughts? Any thoughts at all? You're going to do it on both sides? Turn that fraction away. So you're going to go 1. What? You're going to go 1 minus cosine of x here. But are you just allowed to do that willy-nilly? You can just multiply. No, I'm not talking to him. I'm talking to everybody that's not him. He knew why he was doing it. So up here, we're going to get 1 minus cosine of x. Oh, crap.
Do what? Made it worse?
I'm just saying.
It's not helping?
No, I think it'll take away some of the stuff. It looks like it'll take away the cosine at the end and turn it into a 1, but I don't know. So now we've got sine of x over cosine of x equals all that stuff. What do we want to do next with all that stuff? No right, no wrong. You got 3 parentheses. Perhaps we pick 2 of them. I might FOIL first. Just because. For no real reason, but just to see. So 1 times 1 is 1. That's the first step of FOIL. Outside. 1 times negative cosine is? What'd you say? Yeah, but we're just playing around. Even if you're not going in the right direction, you're still practicing the skills of moving stuff over, moving it back. Like, the whole thing is practice. It's not bad to do. I'm not upset about doing it. I just don't like doing it. Middle. 1 times 1 over cosine is? Dang it, we got back to a denominator. But then... What the heck? Get out. Lastly, but not leastly, don't actually get out. If you leave, you can't walk in late. You know that. I'm just kidding. You can leave.
That's cool.
minus, what's cosine times 1 over cosine? Cosine times 1 over cosine.
Is it cosine over cosine?
Yeah, it's just 1, right? Okay, this is actually starting to look a little easier now. Something cool happened there on the right side. The 1 minus 1 kind of goes away, doesn't it? Turns into 0. Doesn't cancel, but yeah. Sine of x over cosine of x equals negative cosine of x. That's still a little unpleasant. Plus 1 over cosine of x. Oh, wait, I missed something. The sign on the outside. 1 over sine of x. Any ideas? Any thoughts? Any thoughts? I got one.
Put 1 over cosine and 1 over sine to cosecant, secant.
No, dude, we already just got out of cosecant and secant.
I'm not good with sine and cosine.
Well, dude, I'm not good with secants and cosecants.
Okay.
Now we got to mash these things all together somehow. I don't want to tell you, but I see it, but I don't want to tell you. It's on the far right. It's on the far right.
Cosine is over 1, and the other one is
Distribute.
cosine. So if
Is that
it's
what you're trying
1 or 0, is this negative? No? Okay.
Do you distribute the 1 over sine x?
Do we really? No. Yes.
Yeah, I'm just seeing if it helps. Sine, cosine. Then we have sine, cosine, negative. Sine over cosine. No.
Move 1 over
Cotangent.
sine to the other side.
We have cotangent and 1 over sine, cosine. And if we move the other... Yeah, we can do that. It doesn't hurt. So now we're looking at sine of x over cosine of x equals... He said, can't we do distributive property right here to get rid of all these parentheses? Negative cosine of x over sine of x. Now that's looking pretty darn like we're almost there. Like something there is looking similar. Plus 1 over sine of x. Ah, dang it. That one kind of ruined it for me, but that's okay. Any thoughts now?
What's cosine?
Maybe look at the denominator.
You were going to say multiply by sine over sine right here?
Okay.
Oh. No, you were going to say multiply by sine.
Yeah.
Okay, those are two really good things to do, and neither is right or wrong. Dio said you could multiply by sine because it'll kill sine squared up here, right? That's fine. And Kiki said we could multiply by sine here to get a common denominator. They're both good, and they're both going to get you the same spot.
Maybe cosine.
Whoops. Yes, you're right. Cosine. I don't have a preference. You follow either path and you're almost there. Like literally, you follow either of those two paths, you're almost there. I'm going to go this one first just because what I heard. Equals negative cosine of x over sine of x. And then we're going to multiply by 1. But we're going to do it in a really cool way. Right?
Yeah.
We're going to do it as cosine over cosine. Are you allowed to just multiply by 1 somewhere in the middle of a problem? Yes. It's the only number you're allowed to just multiply by. And now that we have a common denominator, sine of x equals 1 minus cosine of... I'm switching these around, right? Just for fun. 1 minus cosine squared of x over sine of x cosine of x, right?
And then 1 minus cosine squared x is just sine squared?
It's just sine squared of x, right? From that formula? Over sine x cosine of x. And then what happens with one of those sine x's cosine of x's? Look at that. We're almost home free. Sine squared and sine. The 2 goes away and that goes away, right? And what are we left with on the right? Sine of x over cosine of x. And what do we have on the left? Sine of x over cosine of x. And if you want to be really cool, you draw a line. And we really didn't do a ton to the left-hand side, except we did get rid of that 1 over cosine of x. So that's a pretty big move. That's fun. That was a fun problem. If you would have chased down Dio's thing, you would have got the same thing. I think you would have ended up with a different final proof thing, but you were going to multiply that sign away, right? Which technically you could have done right here.
Yeah, in the middle.
Right here. That's the step you could have multiplied that sign away before even distributing it, right? Because it's sitting out here. So sine goes away. This becomes sine squared. And now it's on you to recognize that the common denominator you need is cosine. Sine squared over cosine. Ooh, or no, you don't need the common denominator. So you multiply by sine here, right? Goes away. You got sine squared over here. Multiply by cosine over here. Goes away. Multiply by cosine over here, and you get cosine squared minus cosine over cosine, so minus 1. Or, I guess, plus 1. And you'd end up with sine squared equals 1 minus cosine squared. What? Which is just true. All right, any other problems? That one's worth a rework. That one, worth a rework at home. Absolutely. It's just good practice. It's just good practice getting into the rhythm of it. I can move stuff to the left. I can move stuff to the right. I can remember 1 or 2 identities, even if I don't remember all of them. All right, what else are we looking at? What types of problems are troublesome?
I think it's easy, but can you go to question 8?
Question 8's not too easy. Express tangent in terms of what? I'm gonna have you read it since I already did it for the other class, and I don't want to erase it. We'll just do it twice. So question number 8 says, express what?
Tangent of an angle in terms of secant of an angle for an angle in quadrant 2.
So express tangent in terms of secant, quadrant 2. You know, this is actually a funny one. Me in the last class were trying to do it in sines and cosines, and we really had a hard time. But if you look at that first page I gave you, there's a tangent secant formula that's like spot on. Worth maybe putting on your note sheet. Anybody know the tangent secant formula? I think it flows out of sine squared plus cosine squared equals 1, but I could be wrong.
Yeah.
If you were to divide all of these by cosine squared, wouldn't you get tangent right here? Plus 1 equals, oh crap, tangent squared. Sorry, ooh, my bad. Tangent squared plus 1 equals secant squared. That's the formula. There was a third one. I'm going to come back to that. There was a third one. I think it had cosecant in it. I could be wrong. Right? Or I think it had cotangent in it. It's easier to remember. And how do you make, which of these 3 would be the easiest to make cotangent with? Right there. S. Put a sign on the bottom. Put a sign on the bottom. Put a sign on the bottom. And now you're looking at 1 plus cotangent equals cosecant all squared. Not going to lie to you. That might be the first time I've actually memorized those formulas. Now I have the formula. I've never noticed this until literally this moment. I couldn't even get it with the first hour. We were having trouble doing it. I'll need to go back and tell them. That's a really cool way to do it. And then watch this. Okay, so if you're like, whoa, that didn't make any sense. Here's the thought behind that. Is memorize sine squared plus cosine squared equals 1, right? Memorize that. And then just do it for all of them. Don't try to remember which ones to do. Do it for S, right? S squared, S squared, S squared. And you're going to get 1 What is that? So what is that formula right there? 1 plus cotangent equals cosecant. Don't forget to square them all. All right, then do it again. Sine squared plus cosine squared equals 1. But do it for the c. The c is the next one, right? Over c over c over c. Squared, squared, squared. And we're going to get tangent squared plus 1 equals secant squared. But because I'm telling you don't memorize the formula and just do it all, now do it for the 1. Right? Divide by 1, divide by 1, divide by 1, what happened? It's the same. Nothing happened, right? So your thing is, oh, we're making all the formulas we can by this, by just dividing out each of the terms. And so my question then is, which of those two formulas looks like they help with this problem more? I think so, right? Express tangent in terms of secant. So we're going to take that formula, and we're going to say, wait, what does it say to do? So we're literally almost there. Let's be careful, though. I wasn't careful when I was doing this thinking just now. What did I leave off in literally everything that I was doing? No, I got the square. What have I left off of this entire thing that matters a lot? The angle, right? This is not the formula. This is writing too fast and being bad at math. This is the trig identity. All right, and now how do we get tangent by itself? Any thoughts? It's actually pretty darn obvious. I think, oh, that's me. That's not nice to say. I think it's obvious. I think it's an easier move than most of the moves we did today. Yes. I had a physics professor. He was awesome. Loved him to death. I had a physics professor who I'd go to office hours and I want to understand a thing he said in office hours. And he's like, oh, sorry, you just don't understand it. But in class, he would always say the word trivial. He'd always be like, and then we'll just do this, and it's trivial, and then he'll just keep going. Meaning like trivial or like, it's everybody gets this. And everybody in the class is like, that wasn't trivial. Whatever you just did there, nope, not trivial. But having all that, like literally 4 or 5 times a day, just be like, all right, and then we're going to freaking use Maxwell's equation, and that's going to be trivial. Or he'll just be like, apply Maxwell's equation to this, trivial, and then you skip the whole application. Anybody got a thought on how to get tangent by itself? If you want to make your life infinitely harder. Oh, it's not that that's not true. It's that dividing by tangent won't get you. If you divide by tangent, that'll go away, right? And you will have tangent on the left. But you know what you have on the right now? Secant and tangent. So you don't have tangent in terms of secant. You have tangent in terms of secant in itself. That'd be like solving for x. That'd be like x squared plus x plus 1, right? And I say solve for x. And you're like, okay, I did it. X equals x negative x squared minus 1. Because I moved those over. And I said solve for x. And you're like, yeah, this is x, right? That's x. That's not x because you got another one hanging out affecting it, right? So that's kind of like, yes, you're not wrong that you'd get tangent by itself if you did that. But we want tangent by itself and only by itself. Nowhere else. So let's square root it. Square root the whole thing. Oh, this is interesting. So we have tangent by itself now, right? But we have a new thing. The square root that we introduced. And so what do we need to add in front of it? And how do we know which one to pick? Which means? Because if we're doing a real good refresher and not just, oh, some people know the answer. Quadrant 1 is positive, positive, but that's not even as helpful as defining each one. The first one is the, and the second one is the sine. There we go. That's a good, and so the sine is positive, they're positive. Hey, but that's not even a good refresher because we're talking about tangent, and nobody even said anything about tangent. And tangent is sine over cosine, and so it would be positive over positive, which is positive. And I know that's what you thought. This is expressing everything you were thinking. So this one would be negative comma positive, which means in terms of tangent, It means in terms of tangent, tangent is going to be positive over negative, which is just negative. So that would be your final expression there, which is pretty cool. Pretty cool. I'll do this on myself.
So if it gives you a quadrant more than likely, you're gonna get two different answers.
Always.
Quadrant. I thought the quadrant gives you your right answer.
No, she's saying if it has to give you that quadrant, there was something in the middle that made it have to give it to you. They would not have given it to you if you didn't need it, right? And also vice versa. It would have been really, really weird if they didn't give us the quadrant and we got here to two answers, right? Because math would have said the plus or the minus, right? Math says you write that square root, you put a plus or minus. So it's really, really nice that it worked out so that we had some sort of means to use that plus or minus. Namely, the means to use the plus or the minus is, do you know where tangent's exactly the same? I know it's kind of hard. This is a long time ago. Where is tangent exactly the same?
And third one?
Okay, that's where it's exactly the same. Sorry. That's where it's exactly the same with the sign. You're right. If you want to keep the exact same sign, then tangent's going to be exactly the same right there, right? But where's tangent almost exactly the same except for the negative? It'd be in 2. And it'd be where sine over cosine is identical. So it'd be where the angle, well, we don't know exactly what it is, but it'd be whatever dot matches that dot, right? That's going to have the exact same sine and cosine. That same little colored triangle. If you want to use the colored triangles from the unit circle, whatever dot on the thing has the exact same colored circle. So if there wasn't that plus or the minus, I'd be confused because I'd be like, but there's 2. There's always 2 that are the same. If you want a little freebie, 26, 27, 28, just while we're here.
Just cross them out.
They were not got to this year.
We didn't do that.
We just ran out of time, ran out of dates, few too many review days, but it's okay. There's like another set of 4 formulas that look like this, that I was like, you know what? Instead of memorizing 4 more formulas, it's basically, you don't have to write that formula. That was me showing you like, hey, there's another set of formulas that's S times C, S times S, C times C, and C times S. There's another set of like 4 formulas that are product to some formulas. We just didn't have time. There's so many trig formulas. Really, the goal would be at some time in your life that you have the ability to just have the formula sheet and apply it, and without having ever seen anything before, which is hard. That is 26, 27, 28.
Is it going to be on the final?
No. Anybody else got any places they got stuck while working on their review?
I don't know what 25 is exactly asking for.
That's okay. What? Oh, cool. Wait, no, this one's cool.
This one's good.
This one's fun. I didn't do this one with my other class either, so I'm glad you said something. I like this one a lot. I like these ones where there's like an extra step of thinking, and it's not just remember what we did in class, but you actually have to think about what each of these things means. What the heck? What the heck? There it is. Okay. So we got some figures. And we got some angles. And we got something it's asking us for, right?
Look at that. It says find cosine alpha plus beta, but you know that the other angles are going to equal 90 because you already have a right angle. So wouldn't you just get 0? Because cosine of 90 is 0.
But look at alpha and beta. Those aren't the same triangle.
Okay.
Well, it would be cool. Usually in our world, they are, right? Usually in our world, beta goes up here. So you're right. That's where you're saying the 90-0 thing. These triangles aren't the same.
So it's one problem, two separate.
Correct. This is one big problem. That's why it doesn't say it. Oh, it does say A or B down below. Dang it. That's fair. That's fair. No, that's stupid of me. It's one big problem. In that blue box, this blue box should be like flashing sign at your brain. Hey, now stop. We know this. This is a thing.
So we call
What's that thing? You remember it?
like cosine
It's cosine of alpha.
alpha
I know that's the formula. It's fine. Times.
minus cosine SI.
You want to hear a cool way I thought to remember the plus changing to a minus?
Same sign.
Sine has the same sign. Cosine changes. Sine starts with S. Sine, same. Ooh, look at this. Same. Cosine changes. Woohoo, fun. I don't know. It's all that. I mean, it's kind of nice. So we change the sign in the middle because of cosine. Sine has the same sign in the middle. What the? Now we need to know what the cosine of alpha is. They didn't even give us alpha. How could we know the cosine of it? So good to cosine stands for
A over B.
adjacent over hypotenuse. Remember, it's so toa. There's an unfortunate video online of a teacher.
Is it you?
No, it's not me. I'll find it later. It's an unfortunate video.
You just want to suggest this.
No. Cosine of B.
The C is inside It's funny.
A over H again. But for the other triangle. Minus over H over H. But it's really important to think about triangle differences, right? Two different triangles. But we're missing the H for both of them. How on earth could you find an H value when you don't know it? You're saying 1 squared plus 2 squared equals blank squared? You're saying 5 equals blank squared? You're saying that side is root 5? Unfortunately, he's right. Oh, this one did give us H. That's kind of cool. So you're saying this side is the square root of 9 minus 4, which is the root 5. Oh, is that right? 9 minus... Well, isn't that blank squared plus 2 squared equals 3 squared? So x squared equals 9 minus 4, so x squared equals 5, so x equals root 5 again. Lols. Well, they ended up being the same, but they're two different triangles. So for the green triangle, what's adjacent over hypotenuse?
2 root 5.
And for the red triangle, what's adjacent over hypotenuse? Now that's nice. Something happened in there that was pretty nice of the problem to make up for us. And for the green triangle, what's opposite over hypotenuse? And what's adjacent over hypotenuse? No. For the red triangle, what's opposite over hypotenuse? 2 over 3. And so doing a little mathematicas, you get 2 over 3 minus 2 over 3 root 5. You know what we should do. We all know what we have to do. Stop. Circle it. You're done. Yeah, you get most of the points, or probably all, depending on how everybody else is doing on the problem. I'm going to multiply by over, which is actually a double whammy, because not only is it getting rid of the denominator on the bottom, but you see what it's actually going to end up doing for us? I lied, nothing. It's not going to do anything. It's going to have 15 on the bottom now. I thought it was going to get rid of the 5s. It's not. So that's all going to turn into 2 over 3 minus 2 root 5 over 15. Any other cool way to write 2 over 3 that's not 2 over 3?
Is it 15 over 10?
It's close to that. Yeah.
Sorry.
So 10 minus 2 root 5 over 15. If you want to be really perfect and awesome. That would be a solid problem to put on the non-calculator section, but maybe with a 3, 4, 5 triangle or a 6, 8, 10 triangle. Like the triangles that are a little easier in Pythagoras without a square root. That's a pretty cool problem to use. Really, the hard part kicked in at the bottom there with the square root thing. But bless you. Anybody have any other parts of the review that they did not understand?
14.
Number 14. Nice. Thank you. We didn't do 14 yet. Do you think we have room right here? I think we have room right here. Let's try it.
You have the ability.
You know what? I don't want to just do what it says to do, though. So I'm not going to. Nope. I know it says find the angle opposite the longest side. But you know what we're about to find? All of the angles. That's good practice. And I promise you, whether or not test 3 says it, when you take your final, the only triangle questions say completely solve the triangle. I've looked at it. I know that for a fact. So, what? What?
You're looking at the final of the exam?
No, just the past 3 years or 2 years, really 2 semesters. But so no, I haven't actually looked at the final. I'm sorry.
Are you allowed to?
I don't know. Yeah. I mean, I run copies of it, so yes is the answer to that. Who's texting the group me?
Nobody.
Oh, is that a different group me? Oh, different group me.
Is
Sweet.
the calculator portion just triangles?
And the things that are crap. Triangles and any arc sign that's not on the unit circle. So if you look at the last section, there's a couple of them. The only one I know for sure is the 1 over 3. 30, I know for sure is not unit circle. So like if you get to the end, we're not doing it right now, but I'm saying if you get to the end and it's like arc sine of 1 over 3, which is what that one is, not on the unit circle. So that would be calculator. All right, here we go. Let's do this thing. Which angle do we want to find first? Probably the one it says to, opposite longest side. That's 13. That's, what do we want to call it? Capital A for fun? How do we... y'all. I thought of a really cool way to remember this law of cosines. I thought of a really cool way to remember this law of cosines and what it does. What does a C kind of look like? What does a C kind of look like? Oh, crap. You're right, dude. 20 is bigger than 13. Still, though, what does a C kind of look like? No?
Yes.
No, think about a video game character.
Pac-Man.
Yes. Kind of looks like Pac-Man, doesn't it? A C kind of looks like Pac-Man. Okay, so law of cosines, if you think about this Pac-Man thing, on your triangle, the law of cosines has to use a side angle side, right? So it has to make like a Pac-Man. And you know what that Pac-Man is going to go tell us after this? He's about to tell us that side, right? Those are the angles associated with this law of cosines. We don't care about that angle, and we don't care about that angle. They don't even come into play. Only the Pac-Man angles, right? Whatever angle Pac-Man is eating is the one that's affecting this law of cosines. Wuggle, 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 wuggle. Okay, so let's use that mouth that's about to eat that 20 to calculate this thing. So it's what is the formula? 20 squared equals. Now this is just the normal Pythag formula. If you just memorize normal Pythag, you got half of it down. 9 squared plus 13 squared. Here's where it's not normal Pythag. Minus 2 times 9 times 13 times. You're good. It's called the law of cosines. And what is the only angle we said we needed? It's capital A. Boom. Now we just got to solve that problem. So I'm going to go 400.
You lost.
20 squared minus 9 squared minus 13 squared, right? Y'all cool with that? Divided by negative 2 times 9 times 13. That's going to get me cosine. This is a cool way to look at it. And then I'll do arc cosine on the next level. 20 times 20 minus 9 times 9 minus 13 times 13 equals. Anybody get 150? Divided by negative 2. Divided by 9. Divided by 13. And I got negative 0.64 for my cosine of A, capital A. Anybody else? Anybody else? Even try? Wait, what is negative? Is cosine allowed to be negative? Yeah, I guess it is, because it's still going to be a positive number. Actually, oh, that's even cool. Negative cosine means extra credit right here. If you can, no, what?
Why did you divide by those numbers at the bottom?
Because they're right.
You move the other one to the other side. Put a negative there.
I first did 20 squared minus 9 squared minus 13 squared equals negative 2 times 9 times 13 times cosine. Yeah? And then how do you get cosine of A by itself? To be fair, you should have combined all the numbers first with the calculator if you're on calculator section anyways. But I don't know. Sometimes it's fun to do the math. This is actually really interesting. If you can tell me what this means, I'll give you.
In quadrant 2.
Okay, but what does that mean about our triangle? I don't have my wall. Who said that? Good job. Yeah. A negative cosine isn't bad. It just means what does negative cosine mean?
In quadrant 2.
It's in quadrant 2. What are the angles of quadrant 2? 90 to 180. And so if cosine ends up being negative, it's not like, oh crap, it's bad, which I actually thought at first because I know sine would have been bad. Negative sine would have been bad because that would have been over 180, which is off a triangle. Negative cosine just means it's obtuse. It's bigger than 90. Does that angle look like it might be obtuse, the one we're solving for? A looks obtuse to me. All right, so how do we get that by itself? How do we get A by itself? That's not what it's called. It does have a negative sign in it, but it's not called the negative cosine. Cosine And it's not even cosine to the negative 1. It's called the inverse of cosine or arc cosine.
Negative cosine.
Yeah. Invert cosine of negative 0.64. A is approximately 129.8. Yeah? Other people? Do y'all want to give the other two ones a shot? Let's take a few seconds and I'm going to give you to take a shot at B and C.
What was A?
I'll zoom out a little bit so you can see what we did. You could totally just use the law of cosines again, twice. Couldn't you? You could totes just law of cosines it out. Ooh, that's a good rule of thumb. If you find the biggest angle first, and then you move on to law of sines, you're more likely to get a non-resultant other angle. Because any complementary angle you find is going to cancel out with that one and go way over 180. Go. Try to find the other two angles. But you can't beat me. Bet you can't beat me to find B. You might beat me. I'm going slow. All right, did anybody else find a B value?
What'd you get?
Or a left angle? I got 29.9 degrees. Could be wrong. Anybody find a C or that right angle? Nobody did anything? Guys, you gotta take a test on Friday. Chance to practice. Gotta get that pracky in, boys. Any numbers? Any yes, it's right, or no, it's wrong? I'm okay if it's wrong.
That makes sense.
What makes sense? That's fair.
Okay.
Which one did you get? C?
B.
Oh, you got B. Dang it! I want someone to get C, but I want someone to get C a different way than I got B.
I did 180 minus the A and B and got 20.3.
Yeah, that's what I didn't want. I wanted someone to do C with either law of cosines or law of sines to check because that is just assuming I was right on sines, right? You going A, B, C assumes that you were right that second time. That's not helpful.
Well, I did love cosines for my second.
For what?
For B.
Oh, and did you get 29.9?
Yeah.
Oh, well, that's a good check on us two together, right? Because I did law of sines for B. So that's cool. That is a confirmation that's right. Now we can move on to the 180 minus.
Wait, what did you get for C? You?
Arian.
B? Oh, I got 20.3.
20.3? Yeah. No, I got 20.2.
I got 180 minus 129.8 minus 29.9, and I got 20.3.
Close enough.
What'd you get? 21?
20.2.
That's fine. It's a decimal somewhere. It's a hundredth place decimal somewhere. Oh, we gotta find the area. 2 ways to find the area. Anybody know them off the top of their head because they're so smart?
It's like half the perimeter.
Oh yeah, find the perimeter. Hang on, I'm gonna do this. I'm gonna do this. I'm not gonna write equal sign because there's like 3 steps in the middle, right? Area is find the perimeter, find the semi-perimeter, and then do the square root of semi-perimeter, semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C.
Yeah.
That's not my favorite way. I like the other way better. Anybody remember the second way? It looks a whole lot like the normal area for triangles. 1/2. You can do BC, you can do AB, you can do any 2 numbers. Pick any 2 letters in the world. BC times the sine of. Now hang on. As just a rational experiment, what does it have to be? Capital A. Otherwise, you picked B or C arbitrarily, and the other one should be just as true, and it wouldn't. If you said B, then my brain would be like, well, C should be just as true because what if you just switch your variables, right? So it has to be A. It has to be. This is another Pac-Man situation where you've got. What do we have? We have A, B, C, side angle side. That one's way easier, I think, right? It's got to be. So here we go. Let's do it. Which sides do you want to use? I'm going to use 20, 20.3, and 13. I'm going to say area equals 1/2 20 times 13 times the sine of 20.3. And you're done. Luke, if you were asking about calculators, all of these are calculators. All of these where you have to have the sine and the cosine to do anything, super calculators. Unit squared. Oh, are you okay with the other 4? You're content with the other 4 grades in this class?
I'm content with the other 4, so I can move on.
That's
I don't think it can.
Just leave early.
I'm just gonna focus
Just
on
leave
the
after an hour.
calculator.
Focus on what?
I'm just gonna only focus on the calculator.
That's fair. That's fair.
I agree with it.
I personally think the other one's easier. Not the test I made, but just the concepts. Because the calculator can make mistakes. The calculator can lead you to think that the sine of theta is root 2 over 2. And what would you all say theta is? What would your calculator say theta is?
45.
Your calculator would not say that theta is 45. Oh, maybe it would.
Let's see.
Let's see. Arc sine of square root of 2 divided by 2. Close it. Dang it. It does say 45.
Oh wow. I wonder why.
Because it's not in radians. But
I had my little flashcard of the unit circle.
very. But we're wrong.
Look at his face.
It's not 45.
Look on our face.
See, this is why the calculator section can be a little tricky because you trust it too much.
It could be 45.
I even
It
use
could
the
be another
calculator.
angle.
Or it could be
What's that angle?
135, right? Because I didn't ask you for the arc sine of root 2 over 2. I asked you where is the sine root 2 over 2.
You can just write both.
You should write both.
So we went wrong.
No, but
Just half right.
you are halfway there. I wouldn't even say half right because you were fully right. You were just halfway to the answer. You were halfway there.
We were about 200% right. You're 100.
Right? That's like saying someone on a bus is going the wrong way just because they're not there yet. They're not going the wrong way. They're just halfway there.
Because we didn't have those answers. There.
Find it yourself. Anybody have any more problems? Everybody actually did study, or they didn't study. Is it break time? I think it's like
That's
It is. It is break time. Let's take a 5-minute break this time instead of a 10. You don't even just. Technically, the break's not even real. That class just will teach us through the 2 hours. I've watched them. Have you ever seen them walk outside when we walk outside?
We're better than them.
It says on my schedule that it's 12 to, or 12
Technically,
50,
it's
1 to
two
1
different
50.
classes.
I don't have any classes. That is true. Your schedule does say that. All right, we're back from the break. Now back to the good part.
It's not like they're like.
Which one did we say we were doing back from the break? Number 15? Oh, dude, this is such a good problem. I probably just say that about every problem.
You did.
Well, they must all be awesome then.
Well,
You sure about that? All right. We got 2 balloons. No, we got 1 balloon. We got 2 wires. And we have 3. Okay, this is fun. We've got 1 balloon. We've got 2 wires. And we've got 3 triangles.
3.
Where's the
Oh, yeah.
Where's the third one?
It's the whole thing.
Yeah, super big one, super small one, wonky one. Yeah, right? Right? This is the wonky one. This is the super big one. This is the super small one. It might be helpful to go ahead and just,
Is it right? The big one?
is the big one right triangle? Good question.
Let's put it right. too.
It is right because they dropped the line. And if it's not right, then redrop the line and make it a right. Because that's just an invented number. It's not. It's a variable, right? So unless it were a real number, then you couldn't change stuff like that. But
Why do you have it so high up?
When your face drops and you get so serious after laughing, it sounds crazy.
well, it's an administrative.
He's like, and he's like,
All right, that's frustrating. He told me I'd be able to do that. I'm not. I need to send an email. Send a strongly worded email. All right, let's split up these triangles. Small one. 85. What else do we know?
90.
What else do we know?
H.
What else do we know? We know one more thing. You're saying that's 5?
We didn't know that. We had to solve for it.
Right, we had to solve for it. But you can do that in your head, I think, because 85, you know what I'm saying.
Yeah.
Okay? Is there a way to solve for H? Just this triangle alone, just what we know about maths. Is there any way to solve for any of those side lengths? Don't look at the picture, I'm looking at this. Just with the formulas we have, law of sines, law of cosines, all this crap, is there any way to solve for this?
Not
Not as
as
of now. There's not. I wish there was. She was just here.
talking so highly of? Huh?
What?
Huh?
What?
Oops.
What?
Said they never like stopped their class. He was just standing out there on the phone.
Oh, is he? Okay, wasn't Charday just here?
No. Sade?
She
Yeah.
hasn't been here all day. She was
hasn't
even in
been here.
bio.
What? What? Oh, she was here first hour. She just came to 9 and 11. No, we can't do anything else, right? There's no other formula that we have. Because, and this is really cool, couldn't that triangle keep the same angles and be as big or as small as you want it to be? You've got no constraining side length, right? That triangle could grow like you. Now that's not true for a side length, right? If you have a side length, you can't just spread it. But if you have angles, it's just a proportional triangle. There's actually an infinite number of triangles that could go there right now. Okay, let's move to the second triangle. Which one do you want to do next? The wonky one or the big one? Cool.
Little wonky.
The big one?
Okay, sure. Let's do the giant one. I'm gonna make it a little bit bigger than this one. Yeah. This is just this pin goes wobbly for me. You see that wobble? It's really hard to draw. Ooh, wait. Nice. That's so fun. Oh, hang on. No.
For the big one?
90,
I mean, for the, for the
85. Nope. Do we know the other side?
90,
Or the other angle?
15.
That angle is 15. Okay. Do we know any side? Ooh, we know this is H again, right? Do we know anything else?
Well, is it half? It's like,
Yeah, we kind of, right? We know we can't say half, but we can say we kind of know that it's bigger than 100. We know that it's bigger than 100. That's all we know. So maybe we can make a note to the side, but we don't really need to. Let's keep going. I think we need to look for more clues. Wonky triangle time. This is where we get all of the money from. Do we know anything about this wonky triangle? We know 75. What else do we know? We know 100 for sure. Oh, this is the first side length we've had all day. That's really nice. Do we know any of the other angles? We totally do, right?
Minus 180, 180 minus 85.
You're looking right here? And you're saying that angle has got to be? I don't know, calculator that thing. What is it? 180 minus 85? 95? Ooh, that tells me something about this one. $10 degrees? But wait, couldn't I have known it was 10 degrees?
yeah. 'Cause the other one is
From up there? Big triangle minus small triangle is what's left over in the medium triangle. Pretty cool. And if you want to visualize that line, it's kind of like right here, right? There's a skinny line right there doing some work. Okay, sweet. So this is the first interesting triangle we've had. This is the first triangle where I think we can find something out. What do we want to find out? I should have made this a different color. That should be green. That there's no hypotenuse. It's not a right triangle.
we can find the side.
We can find any side though.
Use it.
Which side? You want to find the one that kind of looks like a hypotenuse?
Yeah, the longest side.
You want to find blue side.
Yes.
Blue side. Cool. What are we going to call it? I'm going to call it A since it's the first side we're finding. Cool. And so you're going to say that the sine of... Oh. What? I'm on blue. Now we can do 10. Equals the sine of 10 over 100. Yay? Nay? Maybe so? Crisscross applesauce. You're going to end up with A equals 100 times the sine of 95 divided by the sine of 10. And I got 573.69. That's A. What else could we find?
You can find H.
Whoa. We're on this. We're not looking at the big picture. I'm going a little bit at a time. I'm not rushing to the answer. A little bit at a time. What else could we find?
Middle one.
That other side? The one across from red? And that one's not H, though.
I know that's not H.
Okay. I might have made it a little too straight up in this picture, so it kind of is annoying. But okay, so then we're going to go sine of 75 over B, question mark, is equal to, use the same two ones because why not? They're whole numbers and they're up at 10 and 100. And so B is equal to almost the same formula, isn't it? 100 sine of 75 over sine of 10. Oh no! Why did I add 75 to it? I messed up. 100 sine. No, it's fine. 556.25? Don't just copy me, please. Check it and see if you got the same thing. And so we can go up to our big triangle and we can start labeling some of these sides. We can say that we know that B is 556. And we know that A is 573. What?
We don't need to find both, right? We just need to find one.
Well, we still-
Correct. I had to see how to do the problem. Do you know the next step to do the problem? I feel like you do if you ask that question.
Yes.
What are you going to do?
Find the like the side for the right next to the 100 feet, so you can get.
This? I don't even think you need to do that. What's up?
You know that angle is 90 degrees. Can you just not do sine of the 556 that is found with the 90 and just solve for?
See, I don't even think you need to find that side. What are we going to do after you found this side? Pythagorean theorem? Or hear me out. How are you going to find that side?
What side?
This, you were going to find this side down here, and then Pythag it out. How are you planning on finding that side?
The sign, the law sign for. Okay, I didn't get all through. Okay.
Wait. No, I'm on board. Hang on. So technically, we're right here, right now. You're right here with 556. It's a decimal, but I'm just shorthanding it. You're right here with 556.
Your wiper fluid's not going to shoot out no more.
Yeah.
What?
Are y'all making smart factories? Is that what that is?
Oh, it's your wiper fluid.
No, it's not.
Well,
And you were going to law of sines down here? Holy crap. Wait, this is awesome. Go. Please go. Go down that road. Okay. So one option is to take 5 and blank. And you were probably going to take... Wait, if you were going to do that and then Pythag, couldn't you just cut out the middleman?
Well, you
What
can
do you
do you can do either. You can do Pythag or you can do law of sign, right?
Right. Why would you just cut out the middleman? The red middleman. Aren't you looking for H?
Oh yeah.
You could do that. Totally allowed. You didn't do law of signs. What did you do?
I did sine with the sine and used
You said that sine of 85 is equal to what?
sine of,
Oh, you did do law of signs.
yeah, well,
See, I wouldn't be doing law of signs. What does sign stand for? SOHCAHTOA? Opposite over hypotenuse? No. Yes. What?
Law of signs, though.
But what about this? What side is opposite of 85?
H.
Isn't that what we're looking for? What's the hypotenuse? 556?
Oh, that.
Choop. Can we solve that problem? What?
because yeah.
H equals...
I did the
It's the same thing. Sine of 90 is 1. It's the same thing. This is a shortened version of the law of sines. SOHCAHTOA is a shorter law of sines. Pythagorean theorem is a shorter law of cosines. They're the same. They're where those formulas come from. 556 sine 85, and we get it done. 553.88. Oh, but it's not 556. I should have gone up and grabbed it. It's what? 556.254. Now I'll do times the sine of 85. 554.137. T? Question mark? I don't know. I'll zoom out and pause for a second, unless you regroup on the difficulty of that problem.
But couldn't we just cut out that middle triangle altogether though?
Oh, that extra step we did?
Yeah. And just did law of sines using 573?
Yes, you could have done either. That's why somebody said you didn't need to find both. We didn't ever use 573, did we? Correct. You could have done the exact same thing we just did, but with 573. Or we could have never even found 573 and realized that we were good for the first time. But it's good to practice because you don't know what you don't know what Friday's going to ask you. It may just give you the same thing and say find every side. Possible, allowed, and it's a different problem. Right?
When we have the 90-degree angle, are we not able to use law of sines?
You are able to use law of sines. Watch. Shh. Hey, chill. Watch this color-coded law of sines happen. A good question. When you have the 90-degree angle, are you not able to use law of sines? Wouldn't it be the sine of 90 over 556 is equal to the sine of 85 over h?
I did a sine of 75. I used to do it.
What?
He used the big triangle.
Oh, okay, same thing though. It's
But I ended up getting
different answer.
70. Oh, I think I used the wrong.
Okay, but watch. I just want to point something else. You have two fractions. You know what you're allowed to do is just the cool little fraction things that happen. Because look, our variable's on the bottom. So you know what we do to both of those fractions? I don't cross. Yes, you can cross multiply. There's a faster way to do cross multiplication twice. Flip them both. You're allowed to just flip both fractions. Right? It's cross multiplication and division at the same time. You cross multiplied, and then you divided the term that you started with over there, and now you flipped both fractions. So you're so allowed to just go flip. And when you do that, you're going to be left with 556 over sine 90 equals h over sine 85. Right? I'm confused now.
Sine of 90.
What are you doing?
Sine 90 is just 1.
Why are we flipping up?
Okay, so it's 556 over 1
It's not just the
Sine of 90 is just 1. Right? Now switch these two. Do a little cross multiplication to switch the top and the bottom. And now you've got the sine of 85 is equal to h over 556. H was the opposite side. 556 was the hypotenuse. So we ended up with opposite over hypotenuse anyways. I just took a really short way to get there. Yes, you can use law of sines. Y'all for real? I'm kind of hungry is all.
Hmm?
Huh?
What did you say?
You should follow.
What?
You should follow.
Don't ever say that again.
You could.
Also, no, class will be over before you get back.
When you run the ball.
Nothing.
That pizza's not.
It's not good?
Well, the ones they have sitting out. on
No, the ones
side-
they make you are good.
Yeah, those are good.
I've always just got the slices. They're pretty good.
The slices.
They're alright. If you get,
I like- But people like pizza. Some people just like
Well,
pizza.
it's like they give you like a whole little.
I think it's just 'cause
and you
it
get
sits
4
out for a
slices, that's why I was
while.
saying-
Can you pick your toppings?
Yeah.
Yeah.
So you do like chicken,
Yeah.
bacon,
Yeah.
Yeah.
ranch,
I don't know. Can you put bacon on it?
I don't think they have bacon.
I don't think they have hand up.
chicken.
They have pepperoni, chicken.
Write it down. I'll go get it for you.
No.
Okay.
What else we got?
Maybe
I guess you finished class.
Popcorn and that Chick-fil-A.
Popcorn?
I think it's popcorn. Some of them don't.
So it was like authors, like,
Authors?
Some folks.
She was on our,
of like faculty members that have written books over the.
So if I write a book, I get free popcorn?
No, I think it's just an event, you just get to go, they give you free popcorn.
I thought it was like
What's
fair
her
cookie.
What's happening?
I'd write a book for free popcorn.
Write a book.
For just free popcorn.
Children's book would be fun.
Well, it's not
You can do
free
that.
because you're.
Yeah.
Children's
Math is for everyone.
No, children's book teaching pre-calculus.
Math is for fun.
Math is for fun.
But the number 4.
Oh.
To like relate X and Y to their
Differential equations.
X and Y.
And then I can just have like a 2, but the 2's not or a 5. But the 5's not a 5. You know what the 5 actually is?
2 plus
A
3.
2.
What is
Oh,
that?
it's the dragon. Or lion?
I don't know.
Oh, it is a lion.
It is a lion.
You get a job.
Oh my god.
I think we need to give him as a illustrator.
Please. That was turn into an illustrator.
Where's his tail?
What?
He only has
Where's
2
his tail?
block legs.
All right.
Not even toes.
Does he gotta go find his tail?
Yeah.
No, it's not even
His
a
tail
It's
wiggles.
just like finding the number.
Oh, that's fine. All right. Which one did you say? 30 what?
Whichever you think is the hardest.
I think it's important to do the first one first. Not because it's hard. It's really not. And I'll do it up here. I won't flip it around or whatever. But because it teaches you what we're actually doing here. So, thoughts about this first one and what we should do?
What's the question?
Add one to the other side.
3 sine theta minus 1 equals 0. And it's saying solve for theta. Thoughts? Plus 1. And then? So you should end up with sine theta equals. And how do you get theta by itself? Absolutely. Of 1/3. And that's where you have to ask yourself, unit circle or no? No. No. King, it is on the unit circle. It's not a memorized unit circle fact, is what we
Unless you're
meant.
weird and you memorize.
Okay, so you see what I'm saying? How that one teaches you what we're doing here? So which one?
So we're just solving for theta on
The hardest one.
Why are you looking like that? What's wrong?
In this instance, do you guys put plus or
36.
minus?
Plus or minus?
Wait, what's wrong?
We use the.
What was the question? I'm sorry.
That's for square roots.
31, 32.
So do we have to figure out the other side?
We think 36.
Why are you looking like what's wrong? What was the question?
Is that not it?
He's offended.
That's not it.
160.5 is the other side.
Hold on. Let me look. Oh, it should have been right. No? What's wrong? Oh. You're so dramatic.
We get points start off if we don't do that.
If you write this, yes, you will get points docked off. You will miss half of the problem if you write this.
Right.
If this problem's worth 5, you got 3 or 2.5, but I like to round up. If this problem's worth 10, you got 5 points right now.
Oh, because it's sine inverse.
Yeah.
Plus or minus?
No, dude. Why is everybody saying plus or minus? He just said plus or minus too. It's not plus or minus. It's a different thing. It's a different thing. What is the thing?
I'm gonna find out what the
Oh my gosh.
the other sign is. Yeah.
So what is it? So you can call it theta 2 if you want to.
Was it 180 minus?
It is. What were you saying?
The issue is you have to.
160.6.
Just flapping jaw.
Wait.
Good job. Arian had this. Arian had it like 10 minutes ago.
Wait.
What do you mean wait?
Oh,
What are we waiting for?
I was looking at your decimal. I was there.
Is this true? Is even the question asked. Grab your calculator. Everybody pick up a calculator right now. I'm not letting anybody off this. I want to see if it's true. Type in 3 times. Well, not everybody. If you're on an iPhone, that sucks. You can't. It's hard to do with this iPhone. But sine. And which one do you want to do first? The top or the bottom one? Let's do the top one. 19.47. Close up that parenthesis from the sine. And then what do we still need to do in this problem? Look at the problem, figure out where we are. Use your rational skills of reasoning. -1. Enter. What'd you get?
Ew.
0?
Negative exponent up here.
No, you don't.
Negative 0.00.
Yeah. You should get like really darn close to 0.
Yeah,
Wait,
get
my
really
calculator's
close.
supposed to be this.
Mine is.
Yeah. 10 to the negative 5.
Yeah. Super darn close to 0. But wait, we need to do the exact same thing for that second answer just to see. 3 times sine of 160.53. Close that parenthesis up. Subtract 1. Enter. Same exact answer. It actually looks exactly the same because that sign is exactly the same.
Wait, so you're gonna subtract 180.
That's how we got it, yes. Sine, when you're looking for this second solution, this is just for all of them. Second solutions, sine is 180 minus theta. Anybody remember what cosine was? It's pretty similar. It's pretty darn similar.
I thought it was just like whatever we got.
Not a plus. No. So the cosine's the same. Right there, right? Because the x value is the same. How do you get there? It's what? Minus 360 minus theta. Pretty darn similar. You just went all the way around, right? What? That's only for. What is that only? You're right. Cosine doesn't have a buddy for triangles because 360 minus any theta in a triangle is not in a triangle. What's the biggest angle that's allowed on that triangle? No, 179.
Oh.
Do 360 minus 179. What do you get? 181.
181.
Is that also on that triangle?
No.
You don't have to do the law of cosines for triangles. In the real world, though, you have to do it all the time. You're spinning Tony Hawk, spinning around on the x-axis. You're building a bridge that has, what's it called, yaw? Has yaw? Something like that. Yaw's the downward effect on a plane or something? Or is it backwards? Drag? Force? Like engine thrust, drag, thrust, gravity. Normal force? What is yaw? I want to know what yaw is now.
I think it's like yaw is like
I'm learning.
your angle you're at, basically facing the ground.
Oh, yaw's cool.
Yaw way.
Yaw is the tendency of the plane to rotate. If you were to turn, yaw is the tendency of the plane to rotate with the turn on accident. So, like, if I were to push your arm down, you might want to spin. That's interesting. All right, let's keep going.
Can we do 36 and 37? Anybody else?
Ja, but I'd rather do 33.
Don't you ask us to ask you? He's like, what happened to that?
Right, I did. But
So,
would you like to do 33 or not?
yes, I would like to do 33. It will help me on the exam. Then why add 37?
Because it's a good problem. And if you can do that, you can do 33.
Okay.
But if I stopped at 33 and someone's like, 33 is too hard, I can't try it, then, right?
Okay.
Right?
I said if we could do 37, we could do 37.
You can. But if I stopped at 33 and someone got to it and was like, it's too hard, I can't do it, I'll just go back to the easy ones. Like, stop studying at 33 because that was the hardest they wanted to go, right? You want to go push yourself further than you need to.
But
You think an elevator, you think the safety coefficient for an elevator is exactly the point where it fails? You think they're like, hey, no more than 600 pounds on this elevator, and then at 600 pounds it breaks?
probably.
No, that'd be stupid. That would be the stupidest thing ever, right? So if you're studying for this test, you're like, I can do this really hard problem. You don't want to study up to the hardest problem you can do. You want to go further than that. You want to work on these really hard ones. So this one is, I think, sine of 2 theta, if I'm not mistaken. Minus cosine. Let's do a little curveball because you can watch the video for this one because we already did it. Let's make it plus sine.
Wait, what?
Just throwing a curveball in there.
Why are we changing it?
I'm just throwing a little curveball in there. I don't know what the answer is going to be. But if you want to go watch the video from first 2 hours, we already did 33. Okay. Booby dooby doop. Sine 2 theta.
Two something.
Seems like that was a formula we have. The two, yeah, that's a good way to think about it. I've never thought about it that way. The 2 kind of comes out, right? And you get 2 sine theta. But what else do you get? Yeah. Plus sine theta equals 0. And now the strategy rewinds back to like the beginning of the year. Even though we didn't have sines, we still had topics like this. Kind of. Though I don't see any like terms.
Right.
33, because 33 is sine 2 theta.
Yeah, he
plus
changed
cosine.
it.
Okay.
33 star. Let me see if this is more obvious. What would you do here? If I just gave you this problem, said solve for these,
I was right. We can factor out.
what would you do? You do this right here? Oh.
Subtract the first one.
Oh, dang it. Yeah, I know you would because you like doing stuff like that. Dang it. No, you're not allowed to do that. This is all you have. I know it. That's why I took away the 0, okay?
Can I knock that down?
Zoop, 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 zoop. Yeah.
I hate it.
It should be the same thing.
So what can we factor out here?
Sine.
Zoop, zoop, zoop. You can't do that?
No, he's saying that you can't do that.
Here's a thought. If you were just to divide by sign straight up across the whole thing, it would get rid of it, right? But what have you also just done? Destroyed a potential answer. It's true. It doesn't get you a wrong answer, but it destroys the other potential answer. So you get sine of what's left over.
2 cosine.
2
1.
cosine theta plus 1 equals 0. And now what? Nobody likes it. But what would you do if I gave you this?
Well, the square really messes.
Oh, you would probably just distribute, dang it. Okay, no, I need a different variable. What did you do here?
Set both equal to 0.
Set both equal to 0. Yes. So on the left side, you get sine of theta equals 0. And on the right side, you get. And then you just solve 2 different problems with 2 different answers. Where does the sine of theta equal 0? Where does the y value equal 0? Pi? Nice using of the radians. I appreciate that. And 0? So we got 0 and pi. And 2 pi, although I think the domain of the problem at the top will constrict 2 pi for us. But it's still good to note. And what about over here? We got to do a little math, don't we? The cosine of theta is equal to negative 1/2. So where is the cosine of theta equal to negative 1/2? Cosine is x. 1/2 is short. So it's going to be up here and down here. Tall, skinny triangles on the left side, which is 120. We just used pi. Dang it.
Yeah, I know.
It's okay. 120 degrees and 30 away from the line, which is 240 degrees, which is 2 pi over 3. Good call. And 4 pi over 3. Good call. Oh, look at y'all jumping in with both answers right away. Good job. And not just, maybe it's because I drew the lines for you. Dang it. Shouldn't have done that. Not just reporting 120, but reporting both immediately. That's good. That was what we didn't do earlier a second ago, and now we got it, hopefully. 0, pi, 2 pi 3, 4 pi 3. Hands off. 33 star. That wasn't 33, but now you can go and practice 33 and see how applicable. Applicable?
Are you going to tell us how many answers we should have?
Is it doesn't mean X in blank?
Ah, it's a good question. I don't know. I'd have to go look. I don't remember. My guess is X in the blank. But the blank is of a similar size to the answers. So if it's like a pretty smaller box than the rest of them,
It depends.
or if you all get small boxes all the way down and then you see one long box, that might be indicative that there's more than one answer. I do know that. I don't know if there's like actual blanks. We should do one more.
37.
37? Is that the tangent with the 2 in it? Yeah? No, this is a really good problem. It's really fun. You're not going to like it, but...
We never did.
Oh, it's also circled, so that's good. Okay, cosine, 2 tangent. Yep, but...
Also, what you said?
Okay, read it to me, please, and we're going to go slow. I want...
Find the exact value of
This is a great problem. What is it?
find the exact value of cosine parentheses 2 tan inverse of 9 over 14.
Okay. This is not fun. Thoughts? Any initial thoughts? If you remember from when we did these.
Triangle?
Actually, that's right. And my charge to you would be if you ever see inverse, I wish I had another I word, but I don't. Inverse, inside. If you ever see an inverse on the inside, immediately what should you do? Inverse on the inside, not by itself. Actually, if you ever see an inverse at all, you know what you should do? You said it already. Triangle. Draw a triangle. Ooh, look at what I can do. Dang it. God. No, what? Inverse inside. No, what? Where'd it go? Inverse inside, draw a triangle. What do we know about this triangle? The hypotenuse is indeed 40. What else do we know?
Wait,
not right.
I don't think it's right.
That's 10.
You're right, I'm wrong. Well, you're right about yourself being wrong. Tangent actually doesn't stand for that. Tangent stands for
Sine over cosine.
opposite over adjacent, right? So which side's... So we have 9, 40, and what about that other side? So 81 squared plus 40, what? No. 81 plus 1600 is 1681. So what's the square root of 1681? I think everybody knows that. It's 41? That's on our memorized facts, right?
No.
I'm just kidding. I did it this morning. I typed it this morning. I don't know that either.
Wait, why would we get that?
Okay, here we are. But wait. How does this help me find cosine of 2 theta? Oh, crap. How does this help me find cosine of 2 tangent? I just drew a triangle. That doesn't help me find an answer. So here's the ration that I took the other class down since we're running out of time. Is you really do need to know what this is. This red cloud. You need to know the English name for that. What's the English name for that red cloud? Dang it, it is that. Well, there's another word for fraction that we use for this section, but it's the same word. It's actually in the word fraction. No, it's not. Oh, it is. It's in there. You got to take away some letters.
It's like I'm losing track around, but it's in there.
Yeah, totally. Take away the C. That's
I know, that's why I was like, wait, never mind. Ratio. And if you plug a ratio into an arc trigonometric function, should have made it bigger. So what I'm talking about now is this blue square. If you plug a ratio into an inverse trig function, what does it spit you out? Usually, you plug angles in and you get ratios out. When it's the inverse, you plug ratios in and you get angles out. But wait, now we're going to plug that whole angle, the new angle, times 2 into the cosine. So what are we going to get spit out this time? A ratio. So what do we want to call that angle is the question. What do we want to call that angle? Hint, I've already called it something down below. Theta? And so what am I actually looking for here? I'm looking for the cosine of 2 times theta without ever even knowing theta. And that right there is an equation. That is a trig function. Cosine of 2 theta is?
Take it out. The 2.
It's not the same as sine. It's a different formula.
Like square. There's many of them, right?
There's 3 of them. Cosine squared
Theta,
minus
sine squared theta.
Then there's like a 1 minus.
Write that down. Put that on the flashcard.
that's it. That's on the flashcard. Yeah. What does cosine mean? We've got a triangle now with a theta in it, and we've got a cosine of theta and a sine of theta. What does cosine stand for? Adjacent over hypotenuse squared minus opposite over hypotenuse squared. Pretty cool. So 40 over 41 squared minus 9 over 41 squared. So 1600 minus 81 over 41, which is 19. Is that right? Somebody check my maths.
You got what?
That's a really cool problem. There's like 4 different units in it.
It's cool, but is it like helpful for Friday?
No, I don't know. I don't know that question. I have finished part 1, and it's pretty reasonable. I have not yet finished part 2. Here you go. If you want to, what do we have? 1 minute left? Here's a good minute. Here's a good minute right here. 1B. Don't remember this one. Maybe there's not a 2. Can't remember. 3A?
1B.
4.
Or what?
6.
4. 6.
9.
9.
Ooh, I don't remember about 10. 10's a really good problem, and I don't remember if it's on there or not. I don't think it is. 11.
Are all the questions?
Test 2, part 2, or calculator, which I haven't made yet, but I can tell you right now, one of these 6. Like, that's the only thing the calculator is good for is arc sines, right? And arc cosines. So, calculator, 12. Even though it's not made yet, I just know ahead of time. What?
Do 3 12 questions. Call it a day.
Right. Well, we'll have to do one. What's the other thing that you use our calculator for? There's one other thing that you need a calculator for. I can't remember. Maybe. No. 14. Particularly A, I think.
Did we do that? 1480?
We didn't. I think we did it today.
Yeah.
There 3. Was that 10? 1, 2, 3, 4, 5, 6, 7, 8.
Same question.
What?
Because you said maybe 10. Because you said you didn't know 10 was on.
Yeah, I don't know. I think there might be one of these number 2s on there, but I can't remember for sure. I don't remember everything, but that's 8 out of 10. So there you go. Good luck.
Very gracious of you. Very gracious.